the IPR guidelines of the IETF do apply. We have the blue color pink sheets going on. Please sign them. We have 2 note takers volunteer. Thank you, Laurent and Anna. But everyone else, feel free to chime in on the note taking. We're using the Etherpad. You have the link both in the GitHub webpage and in the official agenda page. Is there anyone using Jabber? Anyone who can use Jabber? Perfect. Okay. If you guys can join the Jabber room just in case if there's something to relay. Haven't been too much lately, but you never know. As usual, we have our GitHub repo where you have the latest agenda and slide material available, and you can see the link at the bottom of the slides. Our agenda for today, some changes done this morning. We're going to now starting with the introduction on the current status of the research group, upcoming meeting activities, and going on then on some bit more detailed reports on WISHI, pre-IETF meetings, OMA, etc. After that, Michael Koster will give us an update on the activities and data model convergence and also W3C community group on schema extensions. After that, Michael McCool will give us an update on the Web of Things. Then we have 2 short presentations, one from Ivalo on this activity that we were already doing at WISHI and looking into how we can use Yang for object universal parsing interface. And Christian Amzus will give us an update on the new transports for co-op design team. After that, the second half of the meeting is going to be focused on the edge. So we will have Dirk presenting outrageous opinion presentation, why edge and IoT will never happen. Spark some discussion there. And will be followed by a presentation on a draft on problem statements on IoT integrated with edge computing. And finally, a demo on edge and IoT. So looking forward to a very interesting session on edge too. Any questions or comments or bashing on the agenda? Okay, then let's get started. Just a quick reminder, since we may have some newcomers here also in the room, the scope and goals of Think Research Group is that we are looking into research issues that we can turn the Internet of Things into reality, really focusing on those low resource nodes, how they can communicate among themselves and also with the wider Internet. We are looking at the big part of the stack, but really focusing on the opportunities where there's potential for IETF standardization. So we start at the IP adaptation layer and work our way all the way to the applications, but not forgetting things like management and security. One thing we're often asked, okay, so what's the relationship with this IoT work in Think Research Group and IETF and elsewhere? There's obviously a lot of overlap, but where we are looking at these research issues, whereas the IETF side is looking, for example, on protocol engineering. In particular, in core working group, a lot of those things we're discussing are common between us, but the standardization aspects are done in core working group and other IETF working groups such as ACE for security, but a lot of the research topics are explored here. And then there's also, for example, the LWIC working group in IETF side looking into guidance aspects on the same area. So that's how these are roughly working together, and there's no clear-cut line, but it's a lot of collaboration between these various groups. Some of the recent activities that we have had, we've been running this long-running work on IoT semantic hypermedia interoperability, WISHI. We have had from bi-weekly to monthly calls for quite some time already. We had a couple of calls between these 2 IETFs, and also we are at a hackathon activity. We also had a meeting last Friday with OMA SpecWorks, and we have had 2 site meetings. Well, there were 2 related site meetings this week. One, this T2TRG work meeting this morning, but also a related meeting on core applications that were mostly discussed in this core and PubSub applications. Next meetings that are coming after the summary meeting will likely be continuing with these WISHI calls, maybe on a monthly cadence, so a couple of calls between the few IETFs. We are planning to continue our virtual meetings with OCF and OMA SpecWorks. Those have been very, very valuable. We don't have anything scheduled right now, but you will likely see something show up. And then, of course, in the next IETF meeting in Singapore in November, we'll most certainly have a WISHI hackathon. And we're also, as usual, very interested in co-locating with academic conferences this year or later. So if you have any good opportunities in mind, please do let us know. But a bit more details on potential for the Singapore meeting. So As you know, we are using these meetings also, since we are traveling around and have a chance to interact with specific communities, we want to use those opportunities to connect with those communities around. So in the meeting in Singapore, there's one very obvious potential point of contact, the Singapore Smart Nation project. It's a big smart city project going on there right now. And especially since they do have some requirements on standardization, which kind of fits nicely where we are looking at. So one potential we are now looking into is like, should we have, for example, before the IETF meeting, something like a Friday work meeting around these topics. And just to give you a bit of flavor on what it could be, and there was a good presentation in the Web of Things workshop about a month ago from the Singapore Smart Nation, and this is one of the slides that they use that I loaned with permission. What they are really aiming for. So as you can see, the Smart Nation platform solutions that they are aiming for must be able to demonstrate ability to standardize, collect, and aggregate IoT data at scale. Sounds, of course, very, very familiar to us. And also guaranteeing authenticated and automated sources, so have security there, secure platform end-to-end, immutable records, and also relevant use cases. So we see there's a lot of potential here, and we are now in the discussions to see what kind of things we could be doing. So if you want to be involved in this, please do let us as chairs know, or if you know other activities in Singapore you think we should be engaging with, please do let us know. But look forward for more information coming on this and potential work meeting in the Singapore IETF. Then research group document status. We finally have an RFC. So the state-of-the-art and challenges. State-of-the-art and challenges for IoT security is now RFC 8576. And that was a good work done by the author. It took quite some time to get it through, but now we have finally done it. Yes, there's a lot of history in various forms, but you know, security is not easy. Sometimes it takes a while to get those things right. But of course, the work doesn't stop there. We do have also another research group document that has been going on for quite some time, RESTful Design for IoT. There's a bit more information on the next slide. We also are planning for a whole set of other documents that are currently individual submissions but do have potential of becoming a research group documents, in particular on Edge and IoT that will be presented later today. Also, secure bootstrapping for IoT is a topic that has been going up and down. We have been working on core applications and in particular core interfaces and thinking maybe some of that information should be turned into research group documents. And also, last IETF and this IETF, we had quite a bit of discussions on layer 3 considerations, on connectivity, on restricting connectivity, on enabling connectivity. We may want to work on some research group documents around that area. And also, in the context of Wishy, we've been discussing this concept of Wishy notes. So short notes on the topics that we have been discussing, what we have discovered, what we have learned, and maybe publishing some of those, either as individual documents or maybe as a collection of documents. So RESTful Design for IoT, the remaining research group document we have right now, there was a small update that had, well, there's a lot of small updates on this document. In particular, we added more information on the IoT specifics. Was that some of the servers are constrained, which is quite different from the big web, where a lot usually the servers are not constrained, and also on the dual roles of servers and clients, that they are usually serving both roles. Also, one of the points of this document is to provide references for more information, so we added a whole bunch of better and more references across the whole document. And then one bigger change was this clarifications on the push mechanisms. And there we are in particular working on the alignment with the core DynLink document, which was actually updated just for this IETF, so we also need to work on some updates on the RESTful design. We're not planning for more information on this before publishing, except perhaps add some information on affordances and also some more details on Coral and how that is now the emerging use that we see in the use for IoT. There is some potential for adding more information on discovery on IoT, but we have to see how do we want to align that work with the core interfaces and research directories draft. Maybe it's going to be just a pointer to some other documents which have more information on discovery. Then the secure bootstrapping draft. So I got a few bullets from the authors of that document, and what they wanted to highlight that in the IoT state-of-the-art security document, they identified secure bootstrapping as one of the key challenges. So they are planning to work on that topic in the context of this document. In particular, documenting some of the terminology and how those terms relate to each other, onboarding, commissioning, configuring, etc. It's a pretty messy field when it comes to terminology, and well, same terms used for different things and vice versa. But this is T2TRG. So it's secure bootstrapping, I think, is the name of the document. Also, the goal is to identify common design assumptions and architecture components that are here, and finally investigating the benefits and challenges of EAP for IoT. So if you're interested in that work, please do check out the secure bootstrapping document and contact the authors. On Wishy, what we've been doing since the last two IETFs, as I mentioned, we had 2 online meetings. Where we were focusing on these online meetings is, of course, planning for the hackathon. We have this IETF, but then also a research agenda. So what are the topics we should be focusing on moving forward in Wishy, but also T2TRG at large? So we have identified so far 6 topics or topic areas that seem to be very interesting for us. In particular, the modeling data and interaction was so interesting that we spent most of the calls we had between the IETFs focusing on that. So that's clearly something we're going to be going forward with, and Michael will address some of those aspects in his presentation. And overall, this whole area of REST-based hypermedia and how it works together with interaction and data modeling. But we do have quite a bit of interest also on the connectivity area, those layer 3 considerations and forward. But then also in network and edge computing. I mean, this of course something together with the CoinRG that we have been exploring, and never forgetting security when it comes to IoT, and finally terminology. That's something what we have repeatedly identified is very valuable to get some more clarity and more contributions. So we're likely to produce some terminology documents going forward. Then quick report on the Wishy hackathon. So this was the 6th time we had Wishy hackathon at the IETF hackathon. This time we had roughly 9 participants, depends how do you count all the people in the table. A couple of participants also remotely. We had 2 key focus areas in the hackathon. One was this IoT data model convergence, and the other one was hypermedia for IoT and coffee making. So briefly more on the data model convergence. What we're working there is how we can use the one data model simple definition format to enable data and model interchange. So one data model is this new activity looking on consolidation of data models, but Michael will be covering more details on that in a moment. But what we did in the hackathon, we were working on, for example, this tool that we can automatically convert IPSO LiveWithM models from OMA SpecWorks to models expressed using the SDF language. And so that tool is currently available online. It's a web-based service, but also the code is open source. You can find that in GitHub also. Based on this work, we did find some good improvement suggestions for the SDF language, in particular on the data type, schema, and constraints that we are now implementing on the SDF language itself. Also, one contribution out of the hackathon was this tool for generating schemas in CDDL. So as you know, CDDL, what we are widely using instead of JSON schema in IETF context, so we can turn the JSON schemas of SDF also into CDDL and use the CDDL tools for that. And as a side product, we did end up also designing at least a first proposal for JSON format for Coral. So that enables you to use your JSON tooling in context of Coral applications. One activity-related test was this binary data extraction. So Ivalo was working on tooling that could extract binary data using Yang. And there was a problem statement written on that, and also Ivalo deployed a playground deployment. But we will hear a bit more about that and the whole Yang object universal parsing interface in Ivalo's presentation. But that was also a good activity at the IETF hackathon. And the other main area was this brewing coffee with hypermedia. So as you all know, I mean, making coffee has been the grand goal of IoT since the late 90s. and the time of the hypertext coffee pot control protocol. So what we were doing here in the hackathon, we were taking a look at the same topic area with more modern tools and techniques, and in particular, what can Coral and Co-op do here? So we have a reference scenario that is what we've been working on. It's called carrier grade coffee machine, also known as Karsten's coffee machine. What we were doing with that reference scenario is that you are describing the coffee machine using hypermedia and make it discoverable. And we had hypermedia clients that were automatically able to discover different menu options, whether you want to have a latte or a cappuccino, maybe with a dash of whiskey on top. And be able to make the coffee selections and then execute on the brewing part. So we have now 2 open source implementations using Coral and Co-op, being able to do all of that. The brewing part is maybe something a bit work in progress. You actually have to plug in a real coffee machine there. But the whole application logic is already there. They're running both on Riot OS, on an actual IoT board, and then also a Python implementation that Christian was working on. And there, in the presentations, you have links for both implementations. Then finally, we had this last Friday, the meeting with OMA SpecWorks. So this is a part of our long-term collaboration and coordination work with OMA, that we are exchanging information and making sure that our protocols and data models are used in a good way in OMA, but also that the requirements that OMA has are addressed by the IETF. So we had a very good live attempt tutorial by Hannes. By the way, all these materials are available in the meeting GitHub if you want to go check them out. We had also a good presentation on the whole object registry model, IPSO live with M2M object, and live with M2M requirements going forward, what the OMA will be working on for the next version of the protocol and data models. We did also discuss document dependencies between OMA and IETF, in particular Resource Directly, DynLink, COP over SMS, and SendML registry. Some of those will be discussed tomorrow in the core meeting. We also had this unconference style discussions. So there were a bunch of topics that could be proposed that are of interest of both of these communities. And then we were discussed those in an informal fashion. We had a whole long list of ideas, but unfortunately we had a chance to only tackle 3 of them because it was so long and interesting discussions on all of them. But again, data model convergence between live with M2M 1DM in particular, what we were discussing, and also the role of the modern hypermedia formats, such as core link format and in particular Coral when it comes to live with M2M. And we also briefly touched the access control modeling aspects. Unfortunately, I don't have more time on that topic today, but you can go and check out the meeting minutes on the GitHub page. That was the brief report from RG current status and recent activities. Any questions or comments before we move forward? Okay, in that case, thank you, and Michael.
Okay, the topic is IoT data model convergence. I'm going to talk about 2 activities that are going on. One is extensions to schema.org for IoT, and the other is one data model, as Ari just mentioned. So for IoT extensions, what we want to do is extend, what we're working on is extending the schema.org model to accommodate IoT semantics. And schema.org, if you don't know, is a public online resource that provides semantic interoperability for web pages, basically, is currently being used. It contains a lot of information and semantic definitions for things you might find in a web page around e-commerce or trying to do something on the web. And it was originally started for search engine optimization, but it's turned into a semantic interoperability framework. So we're extending that in order that these be open and publicly available and everyone can have access to these models. So we're starting to develop models for sensors and actuators as the first step, recognizing that the whole problem is really much larger than that, but you have to start somewhere. So we're also connecting those semantics to what we call features of interest, and I have a little more description of what that is a little later. These definitions are currently based on an emerging meta model that's pretty popular across different device vendors and different service providers. And it's a sort of an affordance model consisting of properties, actions, and events. And those things are rolled up into what we call capabilities. And I have some more detail about that as well. And we're building a community contribution process that's modeled after how schema.org works, but it's intended to include a much larger set of contributors and reviewers. So the meta model is basically a semantic model for the affordances that a device or something offers for software to interact with it. And we call those interaction affordances. There's property, which is some readable and writable piece of state. There's an action, which is how software induces a state change through some parameterization, so things that are more sophisticated than just updating some resource, but actually want to set something into motion or whatever. And then there are events, which is how the device or thing sends information back when something changes. So it could be a state change, it could be a message describing something that happened, and it can be delivered asynchronously using Observe or some kind of message protocol. The meta model has this concept of a capability that basically rolls up a set of events, actions, and properties together to do some common function, like temperature measurement or controlling temperature or turning something on and off. So we try to keep these, small and granular, so we have a system where you can compose things, but they could be larger aggregations, like you could describe an air conditioner as a capability or a pump in an industrial setting as a capability as well. And we also define data types, and the main purpose there is to associate semantic meaning with a piece of data that you're sending back and forth as an event or action. And also provides some data constraints, like you might have to say something is a string type or number type or Boolean type. So that's basically a diagram of the model. You have capabilities that provide interaction affordances of types, events, actions, and properties, and they exchange data items that are data typed. And that's really our whole model. It's really pretty simple, and it overlaps with a lot of what other organizations and vendors are already using in terms of semantic definitions. So we also, though, recognize that just saying here's a temperature sensor doesn't really do much good in terms of semantics. So it's really important to be able to connect these capabilities to things in the real world. And we're using the concept of feature of interest from existing ontologies to form those relations. So a couple of examples of ontologies that are contain features of interest that are at application layer features, like a brick schema has a bunch of definitions from Haystack that talk about things that you might find in a building, and maybe mostly HVAC systems in a building, but other things as well. And then there's some work on this thing called Genevi that describes all of the components of an automobile and many different views of that, mostly for IVI, which they call in-vehicle infotainment or info systems, but also describes the engine and the powertrain and the wheels and the tires and the doors and the seats and all of that stuff. Additionally, you have the problem of quantities in engineering units and things like that, and there are existing ontologies that already describe those. So our intention is to connect to those. In addition, there are some more basic ontologies such as SSN and SOSA and SAREF that have concepts that are useful as well. So we want to be able to use those to extend the definition. And this is all being done in various RDF languages, JSON schema and Turtle, things like that. So this integration allows us to take a feature of interest, like something in a building or a room or a floor or a part of an automobile, apply an IoT schema definition that tells you how to sense it or actuate it, And then also combine that with the parameters of data that you exchange with it. So the software knows sort of what it's interacting with and what influence it's expected to have in the physical world, and also sort of what kind of data to send it. So this is getting pretty close to an end-to-end bare bones semantic system. And these look like this. It's the same basic interaction model with events, actions, properties, data schemas as data types, connected through various RDF property types to features of interest, like has feature of interest. You could just say this has a feature of interest. You can say this is a property of, or this is associated with. There's a set of relation types or property types in RDF that we're creating to enable this. And of course, these are all extensible. We can create some types today and some new ones tomorrow, and they all work together through the magic of RDF. So the status of this is that there are a set of prototype definitions that we've been working on, and we've been using them mostly in the Web of Things work, in the plugfests, and in generating example Web of Things thing description documents to layer semantic interoperability on Web of Things. So Web of Things uses the same basic concepts, events, actions, properties, and we just provide the application layer vocabulary so that an application can identify which thing, which type of thing, which type of event, action, property. And then the Web of Things format basically explains how to operate the API for that and how to operate the security. It's sort of a binding to an instance of something in the real world that expresses these semantic properties. We have some high-level interoperability demonstrations using Node-RED, where you essentially feed in the semantic terms and the APIs can be generated through some automation. And we're currently working on a submission process. So if you want to make some new semantic definitions, you fill out a form and submit it, and we have some automation behind that creates the proposed RDF instances for that. We have a W3C community group, schema extensions for IoT, that is still ramping up. The membership is increasing, and we need to do a little outreach and build that up, but that's going to be the venue for contributions. So there are some IPR agreements that you make when you join these groups, and that basically gives people a framework to submit their information in a way that's IPR safe. And we have monthly teleconferences. There's the next one is tomorrow at noon Eastern time here. Now the other thing that we're working on is just a new emerging activity called One Data Model. And this was driven mostly by SDOs and vendors that, from their perspective, they don't want to compete anymore on saying their data model is so special that you can only use their stuff. There's a lot of motivation now to normalize across all these different data models. So they're driving convergence. And what we're working on first is developing a common definition language that can be used to describe all of these different types of devices and things. That's really the first challenge. And to put a point on it, it's not an API description. It's not something like Swagger or anything like that. It's semantics only. I have a couple of examples. And it depends on having a way of binding a protocol to this to actually use it in a system. So something like a W3C Web of Things thing description can contain a protocol binding. We can use Swagger as a protocol binding or OpenAPI. And I think it's really interesting to consider using something like Coral and combining these semantic terms with a Coral document to provide a REST API description that has semantic annotation. And that would enable you to put in the terms for events, actions, properties, and features of interest and have a complete semantic plus operational description. In one data model, we're using essentially the same meta model as IoT schema, the same popular industry, common industry set of affordance descriptions. And most interestingly, I think we'll end up being able to use one data model as a front end for IoT schema definitions as well. So if these device vendors end up creating one data model format descriptions for all their devices, they will be relatively easy to turn into IoT schema definitions and host them on the web in RDF. So we've built a little DSL, domain-specific JSON format for this, and this is an example of the JSON, but if you strip out some of the punctuation, it's easier to see what's going on here. And essentially, it's making the same kind of definitions you would make in RDF, but just using JSON. So you essentially have, here's a definition that I'm making, and here are its terms, and here are the definitions of the terms. So in green, we see you're defining switch, having a value property that's of type string, and it can contain one of two values, on or off in string. And then we're defining a couple of actions, an action to turn on and an action to turn off. So this is pretty much the simplest on-off capability model that we could express. And there's a JSON schema and a markdown document in a public repository. We're doing the development of this language in the open. Certainly would welcome, if anyone's interested, GitHub issues, comments on what we're doing. I can't really talk about the whole list of all the people that are involved, but there are a number of well-known organizations involved, and we would welcome more. The status of this is we've been working on it for about 6 months. It was suggested from one of the Zigbee Hive meetings where they bring in people from across industry to talk about what some of the big problems are. And the consensus was one of the big problems was lack of a common data model. So we went to create this group to address it. It's not an organization. It's really a federation of separate organizations and invited experts. And we're operating under liaison agreements currently. We have weekly teleconferences to discuss both the legal aspect of how all of this stuff gets licensed so everyone can use it, as well as the technical development. And mostly working on progressing the language description right now and testing it against taking these models from these different organizations and seeing how well it works to build one data model representations of them. And we have participation from a number of members of the Thing-to-Thing Research Group and WISHI involved. Okay. I think that's it. Questions, comments? Good. Good. We're ahead of schedule.
Yes.
Okay.
Okay, so I'm going to give an update on the W3C's Web of Things project, which is actually just wrapping up its first 2-year charter. Actually, there's an interest group and there's a working group inside W3C. And overall, there's about 200 participants, different organizations and people, universities, for example. We just had a workshop, which was mentioned briefly, where we discussed even charter for the next round of standardization. But we also discussed various applications and use of semantics, for example, in the IoT. We also have 2 documents that I'm going to describe in some detail that are now candidate recommendations and are on rec track. We also have several other notes that are informative but are also publicly published. Some of them actually are quite relevant outside WOT, particularly the protocol bindings. So overall, the way the WOT is architected is a set of building blocks, and So in particular, we have, the one we talk about mostly will be the WAT thing description, which is basically a description of a thing or a service that is provided by an IoT device. And it actually uses an interaction model, which is closely related to the affordances that Michael Koster was talking about as before. It's also been, I guess, co-developed with the IoTschema.org. And IoTschema.org is not the only semantic model that can be used with it, but it is definitely one that we've tested with. We also have been working on the scripting API. However, we decided not to make this normative because we're still working on the use cases and deployment models for it. But this is still under development, and it's meant to make it easier to write things like IoT orchestration layers or program IoT devices behavior. There's also this other document, the buying templates. So basically, the thing description describes the interaction at a high level of abstraction, but to actually use it with a particular protocol like CoAP or a particular organization like OCF, you need some additional parameters, and you need things like the URL schemes and maybe header options and, and security options that need to be associated with the thing description for it to actually work. So again, we have two RecTrack items, and we have a note. And this is also going to be a note, as are the security guidelines. So yeah, there's different levels, but basically REC is a full standard. It's a recommended standard, a recommended use. And a note is just an informative document. So a REC is normative and a note is informative. And just a bit more detail on each of these documents. So the architecture is just, it's technically normative, but it's a fairly high-level document that describes the overall use cases and applications. But it also talks about, I guess, the philosophical model or the semantic model of IoT, including our high-level affordances, which I'm going to talk about in a minute. And then the thing description is a more detailed document that gives the exact information model for this document, and also gives a JSON LD 1.1 serialization of the information model. So you have the information model, how it's stored in a database, but you also have how it would appear in a file when recorded as JSON LD. And it's also an extensible format, as I'll mention in a minute. It's based on JSON LD, and you can use external semantics and vocabulary with it. So there's a bit more information here. So I think I just want to mention, start over here. So there's a certain set of constraints about, what has a TD and what does a TD, what role does it play, what kinds of devices can have TDs. Can you have devices both produce and consume TDs? What function will they serve in a network of devices and so forth? We also have a definition, which I think is particularly important in this talk, about our interactions. What is an interaction? And we use this concept of an affordance. So there's a difference, and this is from the user interface, our research idea. So a door handle is a good example of an affordance. So you have a door, and you want to operate on the door, and you got to figure out, how do I operate on this door? How do I open it? And so you want to do a certain thing. At a high level, you want to open the door, but you got to look at the door and figure out, how do I use the door to open it? And there might be different kinds of handles, but you have some information about how to operate on each of those handles to cause the door to open. And so there's really two aspects to the thing description. One are the semantics, what does this thing do and what is it? And then there's the how do I use it? What protocol, what bits do I put on the wire? What protocol do I use to make it do that thing? And so the thing description describes both of these. And in practice, it's this JSON LD 1.1 JSON document. And because it's JSON LD, now it's JSON LD 1.1, which is still a spec in progress. If people have had previous experience with JSON LD 1.0, I really feel sorry for you, okay? 1.1 is a vast improvement. In particular, JSON LD 1.0 was meant to be a serialization format for RDF databases, period, full stop. And it was a horrible JSON document. It had all kinds of weird conventions. The JSON LD 1.1, the goal is to allow people to semantically annotate idiomatic JSON as used in practice. So really what we want to do is take JSON as used in web services or for data flows and be able to annotate it with semantics. And so this is a JSON LD 1.1 document, which means it's much more idiomatic JSON and much closer to what you'd expect a JSON document to look like. And you can see an example here, but there's a typical metadata on top, but then we also have categories for properties and actions and so forth. And actually embedded inside properties are basically the JSON schema data model describing the data model of the stuff that goes in the wire. And all of this can be semantically annotated, and you can pull in a context to describe your external vocabulary. And this is how you do extensions. So for example, if you use the IoTschema.org terminology, you can just pull it in with an external reference like this, and then use those terms with an IoT prefix. For example, IoT Lite indicating the type of device this is. So I think one of the interesting things going forward is how things like SDF and this, work together. So I think in practice what will happen, we'll have an SDF definition for a bunch of data models in various ecosystems. We'll have a compiler that compiles down to RDF-based definitions, right? Maybe JSON LD, that we can then pull in, and then we can annotate this with those definitions. And then when this gets pulled into a database, you typically pull it into an RDF database, you'll be able to pull in other definitions and have all the semantics come along for the ride. So that's kind of how this fits together. The SDF and this are kind of complementary mechanisms. SDF defines data models. This lets you attach data models to protocols and also data schemas. So anyways, these are additional notes, but the most important one here is the binding templates, which describe how the protocol bindings work for particular ecosystems and protocols. And this is meant to be a living document. As we uncover new things that need to be modeled, we'll describe what is the typical way to use those ecosystems with a thing description. Now, our current status, we quite late in the process decided to use JSON LD 1.1. Previously, we used 1.0, but it had too much resistance because of the syntactic difficulties. 1.1 has been a great improvement. We've been working with the JSON LD 1.1 working group in W3C to make sure it has all the right stuff for us to do things in a natural way. And we basically also have a bunch of default values in our system, so you don't have to specify everything. A lot of things have defaults, and you can just leave them out, and I'll do something reasonable. We also have security metadata, so you can declare what kind of security is required to access a thing. This is an extensible mechanism. So we have a few basic things in there already, but the idea is you can pull in external vocabularies. So if someone defines a new format or a new security mechanism for controlling access to a thing, you can declare the public metadata about that. So you can say, what is needed to get authorization to get access to this thing. It's not going to put, private information in the thing. It's just going to say, here's what you need to know to get into the thing. Anyways, these extension points, in addition to the security metadata, you could potentially have additional protocols and header options and things like this. And you can also have the semantic annotation. And actually, the semantic annotation can take place at the entire thing level. It can take place at the interaction level, properties, events, and actions. And it also take place at the data schema level. So particular data elements could have a type, that could be a unit, for example, or, is this an incrementable thing or whatever. So I think that one thing that I presented at OMA, but I don't have presented here, is we've noticed a few places where we need some more work on aligning our standards. So one thing is a lot of standards now use JSON schema embedded inside them. Like OpenAPI uses it, SDF uses it, we use it, but JSON schema itself doesn't really have a single unified formal standard associated with it. There's a draft. This is something we feel strongly about. I feel strongly about needs to be moved along. I think, in addition, the JavaScript and scripting API, we need to more formally understand the deployment model for that, and also figure out how it works with edge computing. Is an edge computing service a thing, or is it a web service? Do I use OpenAPI for it, or do you use a thing description? Is there some common thing we can do that describes both things and web services? And is an edge service a thing or a web service? And Yeah, so in the presentation, these are all live links. If you want to have some reading material in the plane, you have nothing else to read, here's all the specs are. And the important one here is going to be the candidate recommendations for the architecture and the thing description itself. There's many examples, by the way, as well in the thing description. So I think basically last slide. So questions?
Dave Taylor, just on the topic of JSON schema, the closest thing to an official reference right now is json-schema.org. And
yes.
I went there, and this was news to me, so I thought I'd share it. Update as of 27th of May, 2019.
Yep.
The forthcoming draft is in final review. And so it is apparently being maintained at that particular organization, and that's the closest thing we have to a reference right now.
Correct. So as a draft, we reference version 7 in our specs. The trouble is that very few have extended it in various ways to, for example, add options for CBOR and whatever. In the thing description, we use it to describe payloads besides JSON, like CBOR and YAML and XML. How does that actually work in practice? There's also an IETF draft, which has expired, because there was an effort to move JSON schema forward as an IETF draft. And I think that that organization, people working on JSON schema, will be very interested in moving that forward again as an IETF draft. And there are several organizations that need it, and so this is something that I'd like to see happen myself. Okay. Any more questions? Nope.
Carsten Baumann, just as an anecdote on this, this IETF draft you are talking to, that's the draft zip schema 04. That is actually used as the basis for an appendix of a document that is right now getting done in the security incident handling community here, JSON IODEF. But fortunately, they also have a CDDL appendix, so you can find out what it really means. So there are various versions. I think the newest versions of JSON schema.org are also being submitted to the IETF, so you can also find them as internet drafts, and
okay.
You have to check which one you're using.
Yeah, the website only indicated that it was pointing to an expired draft, but they were planning to update it. So I think it's one of these, they need to refresh it to make it align with the 7.7 version.
That might be expired also.
Okay.
But the one that most people use is the 04 that has been expired for a while.
Yeah, yeah. So one challenge here is that we see JSON schema being embedded in several other documents, and there's a real chance for these to diverge, especially when we talk, even if we have common requirements like CBOR extensions. So we really need to, I think, look at this problem and see if we can take that little piece and get that more standardized. Because there really is a need for kind of a generic data schema. And JSON schema right now is used, it isn't the perfect, but it's used in at least 3 places I know of. Okay. Anything else? Okay, thank you.
Thank you.
Okay, so hello everyone. My name is Ivo Petrov, and I will be presenting UP, which is, I will start by defining the problem statement, and then I will describe how we try to solve this problem. So during the Witch Hackathon, we were discussing that all the applications and interoperability that we have been trying to do were great if you have RESTful APIs, but once you have some very constrained networks like LoRa Sigfox, NB-IoT, and others, or very constrained devices, those things sometimes don't work that great because there are some binary formats that are used by people. So in order to try to make interoperability with such kind of devices possible, it's important to be able to understand the data that they are sending and be able to format data that come from other applications so that they can be received by those devices. And after some considering, well, in the IETF, we know how to do data modeling. We use YANK. And we decided to try to use the same thing here as well. And of course, we have the added benefit that once something is parsed, we can then use YANK to CBOR or to JSON, XML, or other bindings in order to have output format as we need it. So here is an example of how this could look like. We have the usual YANK primitives. We can do type defs. We can do we can add some restrictions of the final results. We can add even units so that the data can be semantically annotated. And yes, then we have some specific extensions to the YANK model so that in the end we have the parsing logic. For example, here you can see we can have some information which are the bits that need to be parsed from the binary representation in the position attribute, and using such kind of information we are able to read the binary data and then obtain some usable values that could be sent as JSON or something else. As Ari said, we have a working example that people can play with. I mean, we have like playground where people can submit their own models and their data and see what will be the result. And the link for this is in the Wishy Hackathon wiki page. I can make sure to put it in the Etherpad notes as well. That will be useful. So in the extensions, we have some other useful things like being able to do multiplication and addition of additional, some arithmetical operations with the values we obtain. We can do mapping between values using enums. We can have choice between different possibilities if we know that some part of the format depends on some other part of the payload. Such kind of things are currently also supported. And the idea is to see if there is any interest for such kind of work, whether, an ideal outcome for me would be someone to say, hey, I have this use case and I would like to see if this can fit it, if we can work together to solve it, and any feedback is welcome. So this is just to let you know that this work is being done, and So questions?
Yeah, I think the go back to the previous slide. I think the next one. The second item here cannot be stressed enough. You cannot develop something like this without generating a ton of examples and seeing whether it actually works.
Yeah, absolutely.
So those people who have weird data, Modbus, whatever, it would be really useful to have an analysis how well such a scheme works for you. And if we have achieved a certain level of validation, then I think this would be a very nice thing to go forward.
Yes, Laurent Toutain, is it bidirectional? It means that you can go from JSON to binary? Or?
Yeah, that is the idea, that it should support bidirectional communication.
Okay.
Thank you.
So those of you who want to have a little bit historical perspective, RFC 4997. That's also a bidirectional mechanism for translating between two formats at the bit level. In this case, the uncompressed and the compressed form of a packet. So it's a little bit different, but I think many of the questions that come up when you do something like this are rather similar. So if somebody wants to do an interesting paper, compare 4997 and this stuff. Good.
Thank you.
4997, I think. Yeah, the formal notation. Yes. So that was the most fun RFC I've ever been involved with. Okay.
Here. So what can I just?
You have to step back.
Oh yeah. So here. Hello, my name is Christian Amsus. No. Hello? Okay. And I'd like to give you a brief update on what has been happening in the field of alternative transports and protocol negotiation for CoAP. The history of this is that for quite some time, the core working group has promised to make CoAP available with a single URI scheme over all the transports. And a group of people, that is Bill, Klaus, Ines, and me, have taken up work on this again around last IETF and got together and first tried to state a few goals of what we're actually trying to do in this kind of small sub-working group with what we call our mini charter. So this is not a new working group activity. It's just things that we write up for the authors of the upcoming documents, so that we have guidance and that we can receive targeted input on. So what we set out to do is define CoAP over SMS, which has been around in core for quite some time, to find how we can describe a single URI scheme for all the transports without creating the problems of URI aliasing that have shown up in previous approaches, and to find good ways to announce for CoAP contacted over one transport to announce where the other transports are. So to switch over, for example, from a CoAP over UDP connection to a CoAP over TCP connection. With CoAP over SMS, we're building on the existing working group drafts that have expired and input from OMA where they've actually deployed it. And we're looking into CoAP over SMS particularly for the reason that it is an example of a CoAP transport that is not using the rest of the IP stack, but using something different. There are other transports in the works that have similar properties, but by dealing with CoAP over SMS, we hope to rule out any roadblocks for those other transports. For the single scheme, we are and especially the URI aliasing problem, we are drawing a lot from HTTP's alternative services. And for announcing the active transports, we are building on Bill's previous work in the protocol negotiation document that is so far still being worked on under a core name, but most of this is experimental enough that we are doing it in T2TRG because it is a research topic. We don't really have a clear path on how to get there. Only the CoAP over SMS work is aiming to start in core already, because that should be a simple and known thing. We'd appreciate if more people provided input for this. So we are tracking the goals, the individual problems to solve in an issue tracker. There's the URI. We'd appreciate eyes on both the approaches that we are discussing so far and the overall mini charter. Questions, comments? Yep.
My comment on this would be, first of all, this is interesting work and needed work, but also I think it's a nice example for how we can organize work. So if some people here in the research group want to build a team to work on something, just go ahead. You get a GitHub repository for free. And we have a way to just kick off work in a very informal, very low threshold way. And of course, we all expect a wonderful RFC to come out of this, but right now this is not the focus. The focus is first of all to understand the problem and to see how it can be best solved. You. So, next.
Okay. Let me just try by speaking a bit louder. Now for something completely different. So the chairs asked me to come up with some outrageous thoughts about IoT and edge computing, which I'm also guilty of having introduced to you here in this group some meetings ago. And I delivered. So these thoughts here are actually less defined than you would maybe think right now. So just please bear with me. But so if you ever found yourself, say, sitting in a management meeting with a piece of paper and a pencil, and you're making checks for every buzzword that comes up, IoT, edge computing. This is the ideal buzzword bingo. And the problem is not that these are not relevant areas or say important topics. It's just these terms are so broad. It's almost not possible to talk meaningful about them without being really specific what you mean. So, for example, in IoT, I mean, we all know this. There are all these different, vertical scenarios, industrial IoT, home networks. They have, you can do computing in all of those, but it's going to be completely different. So depending on, for example, you're talking about virtualized servers, maybe Lambda functions, different interaction models, and so on. So I'm not saying there is no compute in these scenarios, because quite the opposite. There are interesting things you would do. For example, in industrial IoT, there are different opportunities and relevant use cases for computing. So, for example, in this schema here and this diagram, you could basically have different realms where computing, so like programmable functions, would be interesting. For example, close to the deterministic networking. You want to have maybe a low latency control function. Some people talk about virtualizing PLC, so putting them in a data center. So that's all computing somehow. But to be honest, ask yourself, so what's the research there? I mean, this is mostly server virtualization. Maybe you have some specialized hardware systems that understand real-time a little bit. But I think this is the IETF, so the challenge here is to identify interesting research challenges. So that's why I'm saying, let's be a bit more specific when we talk about IoT and edge computing. Another completely different example with completely different properties is, for example, data processing. So some kind of pipeline, data analytics, aggregation, these kind of things. They are very successful, very widely deployed systems in the cloud. This is Apache Flink here. I would say we can imagine interesting use cases for IoT as well. But compared to the previous example, these industrial IoT use cases, this is a completely different beast and has different properties. So let's really look a bit into the, say, technical properties, the criteria that are interesting to discuss these things in a meaningful way. So, for example, I think it's interesting to understand what are the interaction models. So are we talking about like stateless function or more like a server actor model? What do we actually mean by edge or maybe in-network computing? So are we talking about intercepting flows, looking into packets? Is it more something like application data units, or just a co-op request response where we trigger computation? Sometimes you have the notion of mobile code. So what is that? So what is your execution environment for that, or how do you program that? And also really important, so what is the security and the trust model in these things? So so what platforms? How can you trust the platforms? How can you trust the functions, the results of those functions? And well, I think we learned meanwhile that it's not acceptable to postpone that discussion. So these are questions that have to be asked from the beginning. And so in the same way as IoT is a very, very broad topic, of course, edge computing itself is used in different variants today. So this is a ETSI mobile edge computing diagram. And well, it's kind of interesting, like to some parts of the industry, but because you can do interesting things. But technically, from a, say, networking perspective or from a also management perspective, I mean, this is just cloud computing extended to external pods on base stations and doing something radio-specific, perhaps. So not irrelevant, but doesn't require that much, say, networking or internet research. So when you say edge computing, what do you mean? So do you mean virtualized gateway platforms? Do you mean this whole continuum from cloud to edge? Or do you mean something like offloading computation in constrained networks, perhaps? Also interesting, possibly relevant. Or do you mean what I showed earlier, like distributed computing, stream processing? So quite often when people say edge computing, they actually mean something like doing something on a gateway with cloud concepts and cloud technologies. And yeah, these technologies are, of course, very well understood, very successful, and widely deployed. So question is edge computing actually the best term anyway? So edge computing, as I explained earlier, often has this connotation of extending the cloud to the edge and basically applying the same technology, the same concepts, but also maybe inheriting the same trust models or trust anchors in those systems. And well, this bears the potential of the danger of well, basically requiring well, dependencies on the cloud. So things like centralization, well, may be promoted or motivated by business models that expect some continuous, contract renewal and so on. So unnecessary dependencies or unwanted dependencies. So that may not be the best notion to start with in the beginning. And so I thought a bit about, okay, so what could be actually interesting in this very wide space from a thing-to-thing perspective. So maybe instead of edge computing, we want to be talking about computing with things or computing for things. And starting from a position where we say, okay, we don't want to enforce dependencies on centralized communication, computing, and security infrastructure. And well, the IETF has, for example, well, we essentially develop things like a CoAP, which is actually quite a nice example of a protocol that just, is rather minimal in terms of complexity, but on the other hand, can provide different building blocks that allow you to realize different scenarios. So simple, request response, observe, so publish subscribe kind of semantics. You can run it over TCP, UDP, all these things. It doesn't solve all the problems in the world, but it's reasonably flexible. And so is that an interesting approach perhaps to address computing with things in this community? And so that's the thesis, of course. I'm hoping to get many comments on this. So potentially interesting directions, if you were inclined to do so, could be start with the idea of decentralized, secure computing with things from the beginning. So enable connecting things in local networks that can establish trust, exchange data, but also maybe offload computation or create distributed computing sessions. That doesn't have to exclude, communicating or, integrating the cloud, but maybe that's not the mental model we want to start with. So I mentioned these very successful event stream processing frameworks in the cloud earlier. So in the cloud, so data centers, networking is normally really cheap. And so that's why it's totally okay to build those systems as overlay, where they have their security and transport connections and essentially abstract from the underlying, say, node-to-node network. That may be a bit expensive in certain constrained IoT scenarios. So because essentially this is a circuit-like connectivity model where it's very difficult for me to say where should I actually offload these computations to. There are orchestrators that know where is available compute capacity and so on, but they don't really know how the network is feeling at a certain point because it's so cheap and over provisioned. Another little issue with this approach is that often we find ourselves in having to translate between different namespaces. So when you're using DNS and so on, that means if we want to, offload something efficiently in a lightweight fashion, well, we may be required to do lookups first and have the infrastructure, the secure infrastructure for that installed first. So one discussion that is taking place in the COIN, Computing in the Network research group, proposed group as well, is to find ways to deal with computing in network in a bit different way, where you are not necessarily requiring overlays, but you could be able to, say, integrate computing and networking a bit closer. So, for example, that distributed computing could also leverage more knowledge that from the network, or could also knowledge information from the network, such as routing information, congestion information, and so on. And you could have a system that would be a bit more self-organized, doesn't perhaps require that much central orchestration as well. So don't have time to go very deep into this, but so maybe you get a bit the idea that the proposal here is to move away from overlays to like something a bit more lightweight, that where you are able to optimize the networking and compute resources in a, say, holistic way. So thinking about interesting, say, functionality or, say, use cases perhaps in, say, computing with constrained things scenarios. So function offloading, I guess, is very interesting for power saving or for load concentration, load management. Things like triggered execution or reactive programming, if this, then that. So when new data is generated. But also, perhaps managing all that data. So when you have mobile scenarios, perhaps offloading data to a custodial transfer or storage service. And then the data processing pipelines that I mentioned earlier. So be able to construct different pipelines in a lightweight fashion. So just a bit of food of thought. When I said in the beginning, IoT and edge computing will never happen, that was of course outrageous. But what I actually meant is, I want to discuss with you how we can make it happen in the IETF and in the Thing research group, because I mean, to be honest, we know that there are so many forums and industry alliances that do something with edge computing, right? So, and we have to ask ourselves, so where can we actually make it then? What are the research questions that are interesting and not yet solved? And what? So I normally prefer doing for these slightly uncharted territories these days is to really pursue an application-driven development approach where you identify a few really interesting things that are maybe hard to do these days with the legacy stuff, and then really do a deep dive and figure out what you actually need to make this happen. But it's really important to really leave that cozy business case level and really try to figure out what the issues are. And so the interesting questions to look at is really what needs to happen. What are the interaction models, the computation models that we would like to support? So what, for example, do we need to agree on? So do we need to agree on a execution platform or just rather on, say, APIs, interfaces, or protocols? The important pillars in my point of view are decentralized lightweight approach, this joint optimization of networking and computing. I think it's very promising, hasn't been done very much. And I didn't mention earlier, but object security is probably also key to a lightweight, non-connection based approach, of course. Since we are doing something with computing and network in the proposed COIN-RG, so I think these ideas here could dovetail quite nicely with the COIN agenda. Perhaps if we could focus a little bit on the, say, constrained things space. So these were my ideas on that topic. Now, flame me.
I think there's one additional challenge for edge computing, especially in decentralized fashion, and that's what's a secure execution environment entail.
Oh, yes.
Because not only the object security, the security of the data being transmitted around, it's like, how do I get a blob of code and run untrusted code in an untrusted platform?
Right.
With other pieces of untrusted code in the same untrusted platform.
Right.
How does that actually happen? And I think there's technologies to do that. There'll still be standards for how we deploy these things and manage roots of trust and so forth.
Right. And do you think there are, say, research questions that this community could look at?
Well, certainly. So, for example, how do I trust a platform, right? So one way is to have the technology kind of nailed down. The other would be to have kind of reputational mechanism to figure out which platforms can be trusted and which code sources can be trusted and so forth. So how can that be managed? Is there any way we can have a reputational system, for example? Might be one possible route.
Yeah. Yeah, cool, thanks.
Carsten Moorman, reputation is a pretty important word, I think, in this context. So the problem that I'm really interested in this context is one word that has been said about 50 times in this room already, but that nobody seems to know exactly how to handle in the IoT space, which is the word event. So there is an event happening, and what do we do now?
Yeah.
Now, if only one event is happening, it's not the big problem, but if several of them are happening and local memories of things are overflowing and so on. We need something like the custodial transfer you talked about. And how do we actually run this in an environment where really we aren't that sure, not only do these things have nefarious jobs that we are talking to, but even if they are all on our side and wonderful, are they going to work? I mean, is a custodial transfer to something that's going to burn together with me in 5 minutes, is that a useful thing to do?
Mm.
And so reputation is not just past behavior here, it's also knowledge about how the thing in all its thingness will actually act in a particular environment.
Right.
And I think that there's so much that we don't understand about how to structure systems. Of course, you can always say, that's the job of engineering. They can plan this and it's all wonderful, but we know that most systems aren't really engineered this way. If I build a single bridge, I can make sure that this bridge is kind of connected properly and so on. But if I have a real IoT system like a smart city or a smart nation or even a home, this will evolve over time, and it would be nice if we had ways to get these storage problems, these problems, where do we put the data, if we had a way to solve them.
Okay, yeah, I agree.
Hi, this is Eve Schuler. So I loved your talk, of course. I like that you were talking about pillars, or at least adjectives that sort of describe the space that we should target. One of the questions that I think will be echoed in the next talk and the draft that's associated with it is, there are many problems in this space, or building blocks. So I love the building block idea. There are many building blocks that we could build, but which are the ones that are most appropriate for this culture, for the IETF, they don't necessarily have to be our expertise now, but become our expertise, but sort of sit squarely in our domain versus some of the adjacent standards organizations. So that, I think you should think about that as we go along. So that was really why I wanted to get up here. But then the other thing that you raised, and when I think about building blocks, is edge computing is completely a misnomer, because it really isn't just about computing. It is about reimagining the data center and all the things that the data center does in a place that's more proximate, because all of these IoT use cases have requirements that really far away cloud can't meet. And so edge computing is a combination of computing and storage and networking and control points and data management and probably some other things. So which of those are our domain to work on? And then when I think of the edge, it's part of a continuum. It doesn't have to be on, it could be on the thing, it could be in the data center, but so there are going to be many edges, there are going to be different proximities from where the action's happening. But I think one of the building blocks that could be in our domain from a thing-to-thing standpoint is that edges and clouds are collections of things. And so maybe the sorts of protocols that get developed to federate things, whether they're things of things or they're just devices, the actual endpoints is almost immaterial, but those sorts of protocols that federate to create edges, collections, I think could be something that are the kinds of protocols I would like to see us at least consider.
Yeah. So, yeah. Thank you. So I understand what you're saying, and so the notion of reimagining the data center, I have some sympathy for that. On the other hand, I was wondering whether we should maybe just start a little bit smaller, and not do all the. Maybe it could be a very constrained data center.
Oh, sure. So let's go back to your constrained. This grows out of some of the co-op activities, so constrained devices. I think the edge challenges that the IoT equals constrained devices, because you're going to do this offload. It can't all be in constrained devices, so it challenges that a bit. So you could talk about the very edge, sometimes called the bleeding edge. So yeah, focus there on the kind of reimagined data center, in quotes, that would live there, and maybe doesn't provide all of the functionality of a data center, but maybe one like compute, start there, or storage. So I would agree, you don't have to make it a full-fledged data center, but think about what those localized collections of things need and want.
Yeah.
Dick, you mentioned that there are obviously all these activities ongoing, even the standards, getting an idea of what the different standards groups do in that space is already a tremendous task. A different way of approaching this topic is, however, by looking at what the folks in the room, for example, are already doing in terms of deployments and learn from that, and maybe take it more from a sort of applied computer science type of approach and see like what worked for them and what didn't work. And if you collect that sort of input, I think there may be also some interesting sort of areas of investigations that arise that actually can then feed back to the IETF community potentially.
Yeah. Do you have something in mind already, or?
Well, Eve was just talking. They have edge computing solution. We have edge computing solution. There are probably 5 other companies in this room who have a similar solution. Microsoft, where's Dave?
Sure.
Microsoft has something. There's folks here from Amazon. They have a solution, and so on. And yeah.
Okay. Thank you.
Carsten Morman, I think the term constraintness that just came up is actually pretty productive. We just have to think about it in a different sense than we have been thinking about in the last 10 years or so. So when I talk to our electrical engineering people and tell them I work on constrained systems, they look at me with large eyes and say, all engineering happens within constraints. And the hard part is finding out what those constraints are. And so when we think about computing for things, we still have a lot of constraints. For instance, most likely we will have significant energy constraints because we don't want to blow all the energy we can save using IoT out for running it. We have constraints in terms of the levels of protection we can afford to these systems, the levels of attention they can get, and so on. So I think we have a set of new interesting constraints here. And I think really understanding those constraints will help us getting from just redoing all the container stuff we do in the big web, but understanding what we need to do to make this really a significant part of reality.
Dave Wheeler. I'm also from Intel, and Eve and I talk quite a bit, so I'm going to kind of springboard off of some of what you said. And you know, I like what you said about constraints, but I actually think what we're trying to do with edge computing is actually take those things with constraints and compose a compute engine near to the problem without the constraints inherent in those devices. So much like what we do in the data center, where we take elements in a rack and we compose them into a platform on the fly, right? And we have protocols and security and things to do that in a trusted way. That's what we really want to do at the edge. So I want to move compute over to this element, but it doesn't have a GPU to do my AI algorithm, so I combine that with something else close by that has that, and put storage over here because it's convenient. That's what we really want to do with the edge, and I think that's kind of what you were saying, Eve. Move the data center down towards the edge. And that's a big vision, but I think we can start off small and take pieces. What are those protocols to do? You know, those 5 questions you had at the beginning were really good, right? Let's look at those, take a piece of that, and say that that's where we need to go.
Right. Yeah. Thank you. I'm of course familiar with these models and solutions. I think it could be one task perhaps, or one interesting activity to find out whether this constrain things and then maybe offloading to more powerful gateways, whether that's the only model or whether there are also, other distributed computation models that are interesting. And so my perspective right now is that maybe it could be more fruitful to not ossify on the edge gateway model.
So I like your idea of a joint optimization of a dynamic system. However, one that occurred to me recently about the building blocks approach that is taken by Core, and that's the problem of emergent properties. So as an example of an emergent property we've got to worry about, that's privacy. So a data format by itself may not really be analyzable in terms of privacy. A data access mechanism, may not mean anything if you don't know what data you're accessing. But together, there could be a privacy risk because the data could be accessed in a certain way or associated with a person or whatever, right? So I think one thing we got to worry about here is that we can't necessarily decompose things nicely. We need to also think how they stack together, which was basically the use cases.
Yeah.
And I think when you look at these joint optimizations, you all got to build additional constraints into that. Like, for example, computation cannot migrate across a national boundary if it has certain data, that sort of thing. And so these things also need to be considered in the design of the system.
Yeah, that's a good point.
Michael Koster, Smart Things. And I wanted to just say that we sort of look at this commercially, and we have more of a compute in the network model. And now I appreciate really the difference between what you're saying as edge versus computing in the network. And so we're taking an application layer approach and decomposing application functions to granular elements like scenes, rules, behaviors, routines, and then find that we can run them in the network on different devices. So I think there's some kind of a semantic interoperability around functions and sort of what you call the little elements of computation that you do that sort of parallels the elements of sensing and actuation.
Yeah, that's a bit what I had in mind. Sounds really cool. Okay.
Yeah, I think that was a good discussion.
And so now to the actual real work. Thank you.
Okay. Good afternoon, ladies and gentlemen. This is the problem state of IoT integrated with edge computing. So my name is Yonggun Hong. I'm working for ETRI. So first, thanks to Chair to provide another time to show our demo. Thank you. So it is the contents. The first we describe what the change on our draft, and second, we'll show a short time our implementation of edge computing. The goal is to support the draft. This is the history of our draft. In IETF 130 meeting, we present our draft first in T2TRG study meeting. That time, the file is the Jerome version. So at that time, we show 2 demo scenario as a use case of edge computing. The first one is smart construction, providing monitoring services of a construction site. And second is a real-time control monitoring system by a rotary inverted pendulum system. And in the last meeting, we present our draft in a free IETF work meeting. At the time, the file name is to 02 version. Okay, for this meeting, we did some major update. First, we changed the file name to specify it under T2TRG because in the last meeting, we got positive feedback comment from floors, especially Matthias, suggest that this work should be done in the T2TRG. So that's the reason we rename our file name to Draftong T2TRG, blah, blah. And second, we integrated the survey and gap analysis. I remember that Xavier presented and discussed at IETF 100 T2TRG meeting. So as a result of the integration, the new author, for example, Xavier, Matthias, Eve, Dirk, were added in this draft. So I show you what is the change in the with the TOC. For example, in section 3, background, the Matthias suggests that we should clearly separate what is the cloud computing and what is the edge computing. So we tried to add the separation cloud and edge computing, and we slightly modify section 4, new chains of IoT. For example, strict latency and jitter, uplink cost, uninterrupted services, and privacy and security. And section 5, there are some editorial changes, and section 6 also, and there are so many changes. Section 7, use cases of edge computing is to rename state of the art of IoT edge computing. The survey and the gap analysis by Xavier's, the many parts are moved to section 7.1, common aspect of IoT edge computing service platform, and then the many detailed text are included in Appendix A, overview of IoT edge computing. So I think that you can find valuable information. What is edge computing and what are the currently used open source product or standard and any other related project. So you can refer some of the valuable up-to-date information about the edge computing. Yeah, this is one of the content of the edge computing in this draft. I would like to discuss the gateway-based architecture of edge computing. I emphasize that this approach, this architecture, do not cover all of the case of edge computing. This is one of a particular way when we implement the edge computing. For example, it looks like the similar to IoT gateway. So to connect the sensor or device, we must provide edge network function in the southbound area. And to connect to cloud network or server, then we need to edge gateway function to northbound area. And more important thing is to this the middle box, edge gateway function. So in edge gateway function, we can imagine, for example, storage, processing, analyze, pre-processing, intelligence, whatever. So we suggest that this kind of the gateway architecture of IoT edge computing. Yeah, but we know that there are lots of the different edge computing approach. For example, edge cloud, edge gateway, distributed edge node, device embedded edge node, etc. So in the next revision, we will add some of the different edge computing approach in our draft. And I would like to ask, is it ready for T2TRG adoption, or do we need more job to do progress? So before decision, this adoption, I want to show our demo. What is edge computing?
Wait. Okay. So can you back one slide? So you're planning to do another revision. Do you have a rough idea when that will be?
Yeah, so in current draft, we only suggest that edge gateway-based IoT edge computing, but our author discussed about we must provide many cases of edge computing, not only gateway-based edge computing. So as the doc says that we must consider also the current environment edge computing also. So we hoped in the next revision, we include this kind of the cases also in this draft.
That's good information, but doesn't answer my question. When you think?
When before the next meeting.
Yeah. Okay, because I was going to ask who is willing to review this next revision, but if we don't know when we get it, that's maybe a difficult question to ask. But maybe I asked it anyway. So when this next revision comes out, or maybe even with this revision, who would be interested in looking at the document and providing a bit of a review of it? Robin, Hannes, Michael and Michael, Laurent, and Carlos?
Okay, thank you.
Great.
Thank you. Thank you. Yeah, this is our the implementation demo. So I know that this is not usual, but as Doc says that there are lots of the edge computing. For example, Amazon, Microsoft, and Google. We know that the companies commercial, the traditional cloud computing company, but nowadays the company also moved to their direction to in the area of edge computing, and the Samsung or Dell or ARM also have interest in edge computing, and there are lots of the projects regarding of the edge computing. So we only so the object of this demonstration is the first show an example or implementation of edge computing based on open source EdgeX. EdgeX is the open source project that is the umbrella of the Linux Foundation LFH. So you can use it, the EdgeX freely. Not only EdgeX, there are lots of the open source regarding to edge computing. So you can choose what is the best for you. Second object, the goal is to providing a mapping between our implementation and architecture in the draft. And finally, the more important thing is to T2TRG adoption support. Yeah, this is the service scenario. Yeah, we prepare the real testbed in the front desk. So after my presentation, I show you the the working scenario. We prepare the three parts. One is to sensing part, and second is to the edge computing system part, and the third is to actuate device part. So what is our edge computing function in our implementation is that we are targeting on provide intelligence. When you talk about intelligence, we are provided to pre-processing data and prediction, the next value, and analyze and control. So to do this, we train the big volume data in other server or other cloud network, and then we copy the result of the training data, that is the .tb file. So this file is to copy our edge system. So if we receive the data, only the inference or prediction works done in edge system. So the main goal of our service scenario is to detect normal situation and abnormal situation. separation, what is the normal and what is abnormal. If we think about the previous cases, the best one is to compare the threshold value. So if some value exceeds the threshold, then we can imagine, oh, this is some accident or there are something happen. But for example, in construction area, there are many vibration, there are many big noise. So if we compare only one time or second time the threshold value, then the result is not good. So our intention is to something more better. So it is related to the machine learning, deep learning. So in this case, if we make some noise, there are some pattern. So in our edge system, it detects it is the abnormal situation, and then it do something. For example, make alarm or make some the action to the actuator. So you can see there are some three things. One is to sensing, and the other to edge system, and the third is to actuator. So that is the thing to thing, we believe. Yeah, this is the test computation. One is the sensing part, edge part, and the actuator part. And this is the software computation. As I said, it is based on HX. So first, the sensor device by the Arduino board, it is connected to device, to edge system, and then it collects data from sensor, and then it pre-process data and prediction, make some inference. And then it analyze control device and actuate device. So the flow is like this. It is a screenshot of each process. So first it receive the sensor from a real sensor, and then it deliver to edge system using the MQTT. And then in AI platform, it analyze and some decision. And this decision will be done in the actuator. So it is the detailed information about each process. The first one is connect device. So it's the real sound sensor. It is a little expensive, and it is now used in the real field. And this sound level meter are connected to our edge system using Arduino R3. And then this data are collected from this way. So in the latest version of the HX, used the Golang language. So we implemented some module in the Golang. This is the pre-processed data and prediction. I know that there are lots of the AI platforms, so you can use any platform as you want. So in this case, we use AI platform, which is also made by the R3. So the flow is like this. And then in analyze and the control device cases. And finally, so I think that the most important thing is to the result or the next step of the inference or the prediction is to make something, for example, the actuator or some device to prepare or prevent something. So in this case, our goal is to, if something happens, then we enable the object detection module. Yes, sorry. So in the normal state, the object detection module is disabled, but if something happen and the edge system predict, make inference, then it enable the object detection module. So I know that this is a very simple question, so please understand that this is not a commercial product. It is kind of the POC cases. Yeah. So in our draft, we propose gateway-based architecture of IoT edge computing like this. And how our implementation is related to the draft, I I try to mapping. So the sound device or actuator are located this area, and the connected device will collect data, and the actual device are located in the edge network function, and then pre-processed data or prediction and analyze control device are located edge computing function. So in our demonstration, we don't have any edge gateway function because we don't have any outbound connection. But if you want to connect to other commercial or other kind of the cloud network, then you can simply make some connection via the edge gateway function. Okay, so next time I show the real working of our implementation, then can I change the HDMI cable to our system? So please be patient. We are changing the HDMI cable to our edge system. So it takes a little time to configure the window and terminal. So after the meeting, we keep our implementation in this desk. So if you have interest, then join us. Then we can explain more detailedly. Because of the differences of the resolution, so it's not easy to find the best place of the terminal window. And
I always tell the students if they're using Linux, then they end the projector, then they have to practice this at least an hour before they make their presentation. Always goes wrong. In interesting ways.
Anyway,
okay, Minseok, could you show our implementation with your camera? Yeah. Yeah, this is the real sensor, and it is connected to Arduino board. And then, so could you show our edge system? So edge system is installed in the laptop. So the laptop has the GPU to process more data. And then, could you show our actuator? This is the Raspberry Pi 3 with the screen, and because it handles the image data, so it used the Intel Movidios NCS2. Yeah. So could you show the screenshot of the laptop? Yeah. So as I mentioned that this is the terminal of the each process. That is the sensing data, and the data is to deliver to edge system, and the AI platform do something for the ML operation, and then the result is to deliver to like this. Okay, so the explanation is a little long, but the demo is a little simple. So if we make a noise, you can find that the value of the next value, there is some change. So as a result, there are some change the Carson and RA, the object detection. So if we cut off, then the change is current data and the next value data inference predict, and object detection module is disabled. Means, could you do once more? So if we emulate the noise, then you can find some change of the noise, the next value. Then it detects, it predicts the next value, and it executes the object detection module enable. Then as a result, some action was done in the actuator. So if we cut off the noise, then it changed to normal state. Yeah, this is simple, but it is a little difficult to implement. Okay, Minso, could you back to the... Yeah, this is the end of our demo. So I come back to the draft. So, okay, thank you for your listening our demo. So I want to your opinion, or comment, or questions, whatever. Thank you.
Kirane, I had a question about the data model that you were using there. We saw some JSON fragments in the demo. Is that something you made up on your own, or is that some standardized data model?
Yeah, thank you for your question. So in the EdgeX, they use the JSON to deliver their internal inner area. So we use the JSON. So it is come from the EdgeX community.
Okay. Well, I was wondering, because I mean, we're also building some standardized data models here at the IETF. CNML, for example, would be interesting to see like how good fit that would be for these kind of cases, and then bring the learnings back. Like, hey, these are the shortcomings. Here it works well. Here's how it could be improved. So that could be maybe something an angle have here.
Yeah, it's a good comment, but I'm not sure. The LFH and EdgeX is the open source project. Their goal is not making the standard, but we can collaborate the EdgeX project for the regarding of this model. Okay, then I try to contact to him.
Okay, sounds good. Thanks.
Thank you.
Yeah, the other interesting observation whenever I'm looking at a demo, I think somebody should write a paper about what good sensors are for IoT demos. So we have had temperature sensors, and these are really bad because they are so slow and it's hard to demonstrate anything. And having a noise sensor also is maybe kind of, well, noisy, yes. And so that's one interesting problem that we all share if we want to demonstrate something. Of course, it has to happen in short. What about CO2? Yeah. Actually, that works pretty well in a demo students made, because they just had to breathe into the system. And then, of course, the CO2 went up very quickly. So that actually worked much better than I would have thought. But another nice thing that came up on last Friday was that we had some component of a standard that had a minimum time constant of 60 seconds for something. And we decided we will never ever do that again, because in testing and in demonstrating things, it means you have to wait for something for 60 seconds, which is completely okay for the actual intended usage. But for what I mean, when you are running your CI test, you don't want to have that wait for 60 seconds before something happens.
Yeah.
So I think these demos always have this interesting meta level of what you learn from them, and of course doing the Linux projector test first is also one of these things. But back to the subject. Thank you.
Yeah. So to get back to what we could do for standardization opportunities here. So we've been talking about this quite a bit, and AI as a service is kind of an interesting thing to have. But what I want to do is be able to plug and play an AI service with a bunch of other things. Just like I can plug and play a sensor, into a system. So I want to use like an orchestration service like Node-RED to plug into a compute service. So what I'd like to see is, first of all, a standard way to describe edge services that fits in with everything we're doing, either open API or whatever. I'd like to see some standardized edge services, regardless of who deploys them. There should be standardized ways to do AI inferencing. There's some interesting standards related to this, like Onyx, describing neural net models that could be used, right? I think AI inferencing is especially interesting because it's not Turing complete. So you can still upload a computation without worrying about someone uploading a virus, because you're just uploading a neural net model. So I think it's a very interesting thing to deploy a service with. I think related to the idea of AI as a service is how can we extend discovery mechanisms. So we have discovery mechanisms for like devices, like IoT things. Do those same discovery mechanisms also work for edge computing services?
Okay, thank you. Thank you for good comment.
Bumi Kasnabich from Jabber, please tell us why you used Kafka. Thanks.
Kafka, because in the sensing data, it makes a big volume of data. So we use the MQTT or REST. So among them, the Kafka is more reliable, the mechanism to transfer big volume of data. So that's the reason we use the Kafka. Thank you.
I would echo what Michael McCool just said about discovery. But one of the aspects, or at least one of the objects that I'm really interested in, is all the data, because I think with all this computation everywhere, that the data gets scattered, if you will. And the question is, if you're going to do computation, how do you marshal the data? Where do you put it after you're done? And that we need some mechanisms for discovering its existence, its access control, etc. So I would argue that there may be some utility to some kind of discovery mechanisms specifically for objects like data.
Okay, thank you. So actually, this draft is the title is the problem statement IoT integrated edge computing. So we are not targeting on the make some the solution or some proposal. So I'm considering of the how to handle your comment. So I know that we can everything in one draft. So I'm judging what is the best way.
Well, let's follow with that. If you think about edge computing as a microservices model, there's a set of services that you can plug together in different ways. One service you can certainly have is a storage service, right? That allows things like serial transfers and so forth, and access control. So I think it's a very important component service we want to consider. That can also do historical data searches and that sort of thing.
You're right. I was conflating your talk and and Dirk's talk, but I think it is the thing to put into this draft is more about the problem statement of we need to find our data if we're going to do in-network compute, and then for Dirk's outrageous opinions segment, it's the what are the building blocks, and maybe one of them is how do you find objects that are not merely the DNS end host address or name.
Okay, thank you.
I like the Jabber question about Kafka. A couple of hackathons ago, somebody was demonstrating something that essentially went into the XMPP group standard that has recently been published, and they tried to build things together with the XMPP infrastructure and didn't quite get it to work. And in the end, they just said, screw it, we are going to do this with Kafka because it's going to work. And what we are demonstrating here is not XMPP, but the actual data model. So we have this interesting little disconnect, which also came up in the question, why aren't you using standards here? We certainly have to work more on aligning the realities of what you actually can plug together quickly today based on some open source projects that are widely used and the standards that we are building here. So that's maybe another piece of work that should be in our minds. And when you are talking about technology like edge computing or computing for things that have a high integration aspect to them, it becomes more and more difficult to ignore this issue. I think with this, we're out of time already for a while. Thank you all for coming, and I hope we can put something interesting together for Singapore, and see you all in Singapore.
Okay, thank you.
Thank you.